Beneath our feet lies a world of mystery, a place so foreign and extreme that it defies imagination. We walk on the Earth's crust, a thin, fragile layer that hides a molten, seething heart. But what if we could journey to the very center of our planet? What would we find there? Welcome to Amazing World Facts, where today we embark on an epic adventure to explore Earth's core. This is the story of Earth's core, a journey that takes us through solid rock, fiery magma, and unimaginable pressures to a place few can even dream of reaching. Hold on tight as we dig deep into the mysteries of our planet's innermost secrets. Before we plunge into the depths, let's understand the structure of our planet. Earth is like a giant onion, made up of layers, each with its own characteristics. The outermost layer, the crust, is where we live, but it's just the beginning of our journey. The Earth's crust varies in thickness, from just a few kilometers under the oceans to up to 70 kilometers beneath some mountain ranges. Beneath the crust lies the mantle, a layer of hot, semi-solid rock that extends down to about 2,900 kilometers. This mantle is divided into the upper and lower sections, where convection currents cause tectonic plates to move, creating earthquakes and volcanic eruptions. But as we go deeper, things start to change. The mantle gives way to the outer core, a vast ocean of molten iron and nickel that flows around the solid inner core. This outer core is critical to life on Earth, as it's responsible for generating our planet's magnetic field. Finally, at the very center, we reach the inner core, a ball of solid metal, primarily iron, with temperatures as high as the surface of the Sun. This is the beating heart of our planet, where pressures are so intense that even molten iron is compressed into a solid state. Our journey to the Earth's core begins with a descent through the crust. But drilling through Earth's layers isn't as simple as it sounds. The deepest hole ever drilled by humans, the Kola superdeep borehole in Russia, only reached about 12 kilometers, just a fraction of the way through the crust. Even at that depth, the temperatures reached nearly 180 degrees Celsius, and the pressure was immense. To reach the core, we'd need technology far beyond what currently exists, a machine capable of withstanding incredible heat, pressure, and the hostile conditions of the Earth's interior. Imagine a drilling rig made of super strong materials that could bore through rock at unprecedented speeds, cooled by a system that prevents it from melting in the extreme heat. As it drills, it would encounter more than just solid rock. It would pass through vast chambers of molten magma, pockets of gas, and zones of intense seismic activity. Navigating these hazards would require precision and advanced technology, but the rewards could be immense. As we descend, we'd learn more about the Earth's geological history, the formation of minerals, and perhaps even discover new forms of life that survive in extreme conditions. After breaking through the crust, we enter the mantle, a layer that makes up about 84% of Earth's total volume. The mantle is a place of slow, creeping movement, where solid rock flows like a thick liquid over millions of years. These convection currents in the mantle are the driving force behind plate tectonics, which shape the surface of our planet. They create mountains, earthquakes, and volcanoes, constantly recycling the Earth's crust. But the mantle is also a source of incredible heat, generated by the decay of radioactive elements like uranium, thorium, and potassium. This heat causes the rocks to partially melt, creating magma that rises to the surface to fuel volcanic eruptions. As we travel deeper into the mantle, the temperature and pressure continue to rise. Here, rocks are compressed to such an extent that their structure changes. Minerals that are stable at the surface become unstable, transforming into new forms that can only exist under these extreme conditions. These transformations release heat, adding to the mantle's overall temperature. But despite these harsh conditions, the mantle is still solid in most places, though it flows very slowly. It's only in certain regions, like mid-ocean ridges or mantle plumes, where the rock partially melts to create magma. Exploring the mantle could reveal much about the Earth's past, as well as clues to its future. Understanding the mantle's dynamics could help us predict volcanic eruptions, earthquakes, and other geological events that impact life on the surface. After descending through nearly 2,900 kilometers of solid rock, we reach the boundary of the outer core. Here, the solid mantle gives way to a sea of molten metal, a swirling, churning mass of liquid iron and nickel. The outer core is a vast, turbulent ocean of molten metal, where temperatures range from 4,000 to 6,000 degrees Celsius. This intense heat is generated by the decay of radioactive elements and the residual heat from Earth's formation. This molten metal is in constant motion, driven by the rotation of the Earth and the heat rising from the core below. As the metal moves, it generates electric currents, which in turn produce Earth's magnetic field, a protective shield that deflects harmful solar radiation and cosmic rays. But the outer core is not uniform. It's a dynamic environment where complex currents interact, creating variations in the magnetic field. These variations can cause geomagnetic storms, which can disrupt communications, navigation systems, and even power grids on the surface. Studying the outer core could help us understand these magnetic anomalies and predict geomagnetic storms, which have the potential to impact our modern technological world. At the very center of our planet lies the inner core, a solid sphere of iron and nickel, surrounded by the turbulent sea of the outer core. Despite the extreme temperatures, the immense pressure here forces the metal into a solid state. The inner core is like Earth's beating heart, a dense, solid mass with a radius of about 1,220 kilometers. The pressure at this depth is over 3 million times greater than at the surface, and the temperature rivals that of the Sun's surface. But the inner core is not just a simple solid ball. It's composed of two parts, the inner and outer inner core, each with its own unique properties. Recent studies suggest that the inner core may be rotating at a different speed than the rest of the Earth, creating complex interactions that affect the entire planet. This differential rotation could explain certain anomalies in Earth's magnetic field and might even influence seismic activity. But the inner core remains one of the least understood parts of our planet, a place where science is still catching up with the mysteries that lie deep beneath our feet. Understanding the inner core could unlock the secrets of Earth's formation and evolution, giving us insights into how our planet has changed over billions of years. Exploring the Earth's core is no small feat. The challenges are immense, from extreme heat and pressure to the technical limitations of drilling through thousands of kilometers of solid rock. But with advances in technology, we're getting closer to unlocking the secrets of our planet's interior. In the future, we might see the development of new materials and technologies that allow us to drill deeper than ever before. From heat-resistant alloys to autonomous drilling robots, these innovations could bring us closer to the core. But drilling isn't the only way to explore the Earth's core. Seismology, the study of how seismic waves travel through the Earth, has already given us a glimpse of what's inside. By analyzing how these waves bounce and refract through different layers, scientists can create a map of the Earth's interior. These seismic studies have revealed much about the structure and composition of the Earth's core, but many questions remain unanswered. As our technology improves, so too will our ability to explore these hidden depths. The ultimate goal of deep Earth exploration is to understand the forces that shape our planet, from the movement of tectonic plates to the generation of the magnetic field. By studying the core, we can learn more about Earth's past, present, and future, and perhaps even discover new ways to protect our planet from natural disasters. The Earth's core remains one of the last great frontiers of exploration, a place of unimaginable heat, pressure, and mystery. While we may never physically reach the core, the journey to understand it is just beginning. From drilling projects to seismic studies, the quest to explore Earth's core is driven by our innate curiosity and desire to understand the world we live in. As we continue to push the boundaries of science and technology, who knows what discoveries await us in the heart of our planet? Thank you for joining us on this incredible journey. Be sure to like, subscribe, and hit the notification bell to stay updated on all our future adventures. Until next time, keep exploring and stay curious.